Welcome to Ask and Learn.
Hello student. So the question is to calculate the mass of the precipitate which is CrPO4 formed in this reaction. So in step 1 we'll be calculating the number of moles of the reactants individually. So here first we'll calculate the number of moles of the Na3PO4. So here we'll be using this formula where the number of moles denoted by N is equal to the molarity into the volume in liters. So here we have been given the concentration of the Na3PO4, which is, so here the concentration of the Na3PO4 is equal to 0.3 molar, and the volume of Na3PO4 is given as 45.5 ml. So we need to convert it into liters, so we'll divide it by 1000. So it is equal to 0.0455 liters. So now let's put the value over here to calculate the number of moles of the Na3PO4, which is equal to, so let's put the value. So the molarity is 0.3 molar multiplied by the volume, which is 0.0455 liter. So here it is equal to, which is equal to 0.01365 moles. So this is the number of moles of Na3PO4. Now similarly, we'll be calculating the number of moles of the CrCl3. So here we have been given the molarity, which is the concentration of the CrCl3, which is equal to 0.2 molar, and the volume is given as the it is given as 4 point, which is given as 44 ml. So in liters it will be equal to 0.044 liters. So now let's put the value over here in this formula. So here the molarity is 0.2 molar multiplied by the volume, which is 0.044 liter. So by calculating it, we'll get the number of moles, and it is equal to 0.088 moles. So this is the number of moles of CrCl3. Now we'll need to find the limiting reagent. Now the step 2 is to find the limiting reagent. So here, as from the equation given here, we can see that the reactant, the 1 mole of Na3PO4 is been reacted with 1 mole of the CrCl3. So here the mole ratio is of 1:1. But as we can see here, the actual number of moles of Na3PO4 is 0.01365 moles. So the number of moles of the CrCl should be equal to the number of moles of Na3PO4, but here it is the less than the number of moles. So it is the more the number of moles of the Na3PO4. So here the number of moles of the Na3PO4 is lesser the number of moles of CrCl3. So here the limiting reagent is thus is the Na3PO4. So here thus the amount of the precipitate produced will be equal to the number of moles of Na3PO4. So here let's write it. So here the number of moles of Na3PO4 will be equal to the number of moles of the CrPO4, which is equal to 0.01365 moles. So now in step 3 we'll be calculating the weight of the CrPO4. So we'll be using this formula where the number of moles denoted by N is equal to the weight divided by its molar mass. So first we'll be calculating the molar mass. the molar mass of the CrPO4. So here it is equal to, so here the chromium has the atomic weight of the 52 gram per mole plus the atomic mass of the phosphorus, which is 31 gram per mole, plus the atomic mass of oxygen, which is 16 gram per mole, multiply by 4, because there are 4 atoms of oxygen in the compound. So here by calculating it is equal to 147 gram per mole. So this is the molar mass of the CrPO4. Now let's put the value over here to calculate this weight. So here the weight is equal to the number of moles into the molar mass of CrPO4. So here the number of moles calculated is 0.01365 moles, multiply by the molar mass, which is 147 gram per mole. So by calculating it, we'll get, so here the weight is equal to 2.00655 gram. So this is the answer. I hope you find this video helpful. Thank you.